Hello everyone, my name is Jeevan. In this video, I will talk about what is firewall, why we need firewall, and types of firewall in detail. So let's get started. What is firewall? So firewall is sort of device which can uh, control the traffic flow. It can block the traffic, unwanted traffic, or it can allow some specific sort of traffic uh, in a one direction and can block in other direction, and the blocking and allowing decision can be done using several uh, source and destination combination that we can define in a firewall rule set. But for now you can understand the firewall is a device. It can be a physical appliance or can be a software, uh, virtualized software application into some of the platform which can take a decision to whether to allow this or block it, back and forth. So now the question may come, why we need firewall. Because if you see the network connectivity of any company, that will be somewhat similar like this. You may have several computer systems, the servers or user machines. Those may be connected either via wireless system or maybe on a switch, and the switches further can be a layer 2, layer 3, and the router, then further firewall and all. Uh, if you're interested, I can prepare a separate video on this, what is switches and what are types of switches and what are their capability and the routers and all. But that's going to be very detailed topic. For now, you can see here in the network, any network can have such sort of devices in a different form and segmented in a way like this. So they may be connected to some switches, and you may have some server here, or maybe this is maybe your user machine, which this machine may need to reach to this server within your data center, or this machine may need to reach to something in the internet all the way from this gateway to this. So switch control this all segmentation, but then if some machine or some user need to access anything over the internet, the traffic will go all the way this to switch and this router. The router takes the decision where to send this traffic, the routing decision, whether to send this side or this side, and then it can take all these routing decisions. Uh, so why we need a firewall? The basic capability this controlling, I said in just recently, the firewall can we can define a traffic pattern flow and control the traffic, whether this should be allowed from this to this machine can reach to this or not. We can do this using this L3 switch or on the router as well using access control list ACL. So then why we need firewall? Why we need to spend a lot of money on this another box here on my server? Uh, so because the firewalls are very expensive as well. So there is a several reason, because the yeah, of course we can control this communication from here to there, even going out using this ACL into the router or an L3 switch. But the big problem is the maybe that these boxes, the router and firewalls are designed to have some LAN switching context switches role, and the router has a routing decision uh, to. So this may exhaust, one reason that it may exhaust these boxes utilization, because if we keep putting more and more ACL to control here every traffic pattern, so may uh, exhaust this router, and this may hinder this router to perform its actual work, which is routing decision. This is one. And another is the router ACL is sort of limited capable. Uh, so the ACL, yeah, we can have the control based on source and destination port, and where we can control this patterning, but these are more like a stateless communication, we can say. I will talk about under the firewall types here, the stateless, stateful, and all. So the router ACL and firewall uh, has a big difference. Uh, because the router ACLs are not a straight maintainable. Meaning, if you need to allow, let's say if you have a allowed under one ACL that this machine should able to reach to this server here, then the return traffic, you'll also have to allow this return traffic as well. Let's say the server needs to communicate here, so you can't put that control, and it does not maintain the connection states as well. So it require a bidirectional communication allowed. They are not a state maintainable, so they're not that intelligent that what the firewall security policy can take. It can take the decision based on the streaming and maintain the complete connection and evaluate that for future attempt as well. So every time this machine will try to reach their server, then there will be connection formed and communication be allowed, but after some time it's going to kill, it's not going to maintain that connection. So that's why it's a very memory intensive process. So that's why router uh, let router do its role, and the firewall come up with the more capability to controlling and all. So that's briefly, but now here I'll also talk about types of firewall. So there are various types of firewall available there. Uh, the majorly the circuit-based firewalls, which used to be working based on circuit connection from one source to destination, and the packet filtering firewall. The packet filtering firewall takes decision based on the packet filtering per packet filter decision it makes. So if the communication is from one machine, the source to destination, so it's going to take the decision or allowing per packet based filtering, not maintaining a streaming uh, filtering. Then stateless and stateful firewall. So this these are the firewall. Any firewall can be stateless. The majority, the previously, I mean the older one are mostly the stateless, but recent one almost all firewalls are stateful firewall now. The stateless or stateful is about maintaining the state of the communication. As I spoke in ACL context, it doesn't maintain the states. Meaning, what is the state? State is like a uh, when any source and destination make the communication. Let's see, let me open the and show you this how this work actually. Just give me 1 second so I can draw this here and quickly. Let's say you have a one machine here, and this is maybe your target system, and this may be your firewall. So when you when this machine may try to connect this one, yeah, of course there will be switch a router in between. I'm just briefly trying to explain you how this will be, this operation will work. So this is source. So this guy has a IP address, source IP, and it will target to the destination IP. So it has the port, source port, and the destination port. So these four combination goes in a connection. This guy needs to connect to this one, so it will uh, hit this destination IP and a port. So the port is a layer 4 transport layer port. It can be TCP or UDP port. So this firewall have a rule set allowing this tuple that hey, if this is source and this is destination IP and this is destination port. The source port is widely allowed. So all default ports 0 through 3, 3, 6, 355, all these combination 35,000 or 36,000, whatever that range. So this whole range is allowed. We don't need to allow the source port, but we just allow the uh, destination port here. So destination port we have to mention here. Let's say we need to allow the communication for port 80. So we'll have the rule set here will be the source IP and the destination IP and destination port. and then action. The action can be permit or deny, or somewhere in advanced firewall you'll see trust, or maybe just monitor sort of operation, or you may just reject somewhere. So the operation may vary from vendor to vendor. But for now, you can understand the action can be permit or deny. And more more granularly, you can log that session as well. So you can see that later, that what was the action for this combination. So when I'm talking about the states and also, when this source try to connect to this destination on this combination, the destination IPN port, this firewall will check the rule matching from top to bottom, and as soon as it finds the rule matching, and the action can be either permit or deny, and if it is permit, it's going to form the connection table here. So the connection table will be sort of like this. It will keep the source destination port, source port, that can be any random port that source is uh, setting when the source will make the connection to the target. Then against it's going to give a session number here. So that is what this states it maintain, and once as soon as this combination is allowed. If it is denied, it's not going to form this connection. The connection number session will be an upper layer even. So connection number here. So connection form in a connection table. So this connection entry in the connection table will be useful for future connection. Let's say after 30 seconds or minutes, or uh, this source again try to send something to the destination, so it will not need to do this again all the way. It will just check its first the connection table, if it is there any existing connection, so it's going to raise that connection and allow this communication quickly, so it gives the faster response as well. It has some age or ideal time sort of value set. When this value met, it's going to delete. It this mechanism helps to maintain the or avoid the future memory exhaustion as well, because let's say we keep creating connection to memory, and it's going to take some memory space in memory as well. So if you do not uh, delete the obsolete connection, the older connection which are not in being used for some X period of time, then there will be exhaustion in table, so probably it may stop creating a new connection. So for this avoid this issue, it also have a mechanism to control. It has a value set. So as soon as the idle timer met, that can be a default value, or we can set the custom value there. If as soon as that met, so this is going to uh, delete it from this entry will be deleted from the connection table. So maintaining. So when I was saying the less firewall, the firewall is not going to maintain such connection table entries. And every time, whenever this source will destination talk, so they are going to create a new connection every time. So it's again somewhat similar like the router behavior. But in case of the stateful, it's going to maintain the connection, and so uh, the future connection, it will not have to redo this whole thing again and again if the connection is effective in idle state laying in the state connection table. And another is we don't need to allow the bidirectional as well. Let's say the return traffic. Previously, the older firewall, we used to have the rule set to allow. Let's say we are allowing this for return traffic. When this server will return to this query of this client, so we have to have a rule in firewall. One rule for allowing uh, this direction, and another for return traffic as well. So we don't need to have the return traffic rule allowing for this even single attempt. So this is the another benefit of stateful firewall. Then layer 4, layer 7. So that's not nothing biggie. It's just about the OSI layer base capable firewall, which firewall can inspect up to the which layer level. So when I say the layer 4 firewall, the firewall which can take decision up to the layer 4 of the OSI. So there are 7 layers in OSI model. So that goes from layer 1, the physical data link, then layer 3 network, and 4 is transport layer. If you're interested to understand how this works, the OSI layer, and how this traffic flow go in all the way then in this logical uh, uh, standard, you can put that in comments so I can prepare a separate video on it. But for now you can just and it's a really very good concept for it will be useful every time uh, in every troubleshooting or every concept we need to uh, implement or determine how it's going to work. So it's a backbone of this transmission and communication. So go through it. So for now, the layer 4 is a transport layer. So if the firewall is capable to control the traffic up to the layer 4, which is transport layer, the firewall is just going to take decision based on the uh, up to the layer 4 tuples only. So it will just check the source IP, source port, which will be default port, then destination IP and destination port. These four things only. Because the layer up to the layer 4 it is just port. The port can be TCP or UDP. So the fire will take decision based on each combination. If those combination match for any traffic rule set that we have set in the firewall, it's going to either allow based on the action defined or deny it. But in case of layer 7, so these are a deep inspection firewall, we can say, or next generation firewall, which can go up to the layer 7, which is the application layer. So they may take decision up to the layer 7 as well, not just this. So they are going to control the traffic up to this combination. Top of it, it will also check once this is allowed, then they will check, these firewall will check whether what is the application at the layer 7 as well. So layer 7 application, like if it is HTTP, HTTPS, DNS and all. So let's say we have one rule allowing source destination port 4443 port, but under application in the layer 7, if the firewall is layer 7 capable, so we can have further control at the layer 7 as well. Under layer 7 we can, because in the layer 7 there may be n number of application which may work on 4443, but by default it's HTTPS traffic, but under it there may be application tunneling and what sort of application inside this HTTPS. It can be Facebook or Twitter or maybe Google's website or any sales e-commerce site or any instant messaging over HTTPS. So there may be different sort of traffic. So if the firewall is capable to handle, understand the traffic, inspect the traffic up to the layer 7, it's going to go that deeper and dig that and understand this traffic based on the application, not just based on the port. So these are the very advanced. Currently, um, almost all firewalls are layer 7 capable, so they can take decision based on the application and can also check the content into the application, and so which is all about the application awareness. This is we can talk per specific vendor as well, but for now, you can say they are going to take decision based on the application ID or the contain ID or any URL category and all. So they are very advanced and intelligent. So they have a IPS IDS capability inbuilt as well. If you want to know how IPS IDS work and what is all about, so I can let me know. I can prepare separate video on on this topic to explain as much as I can explain this part. So now this is all about layer 7 and layer 4, that is just the capability wise and how deeper the firewall can go to inspect the traffic. And router ACL versus firewall, I already explained. ACLs are somewhat stateless connection, and we have to allow bidirectionally, and they do not maintain the connection. But the firewall are both can be stateless and stateful as well. And firewall has a lot of are designed to do majorly this controlling traffic and inspecting traffic, and but the router is designed to do more on a routing decision. And this, if there are L3 switch also, we can have the ACL there as well, but they are also designed to perform the switching into the network. So it's like more overhead on them. And so that's the one of the reason to have a separate firewall, whether it can be a virtual or appliance based. So that is also very interesting topic, whether we should have a physical firewall or a virtual firewall. That is also an very interesting and debating pointer. So, but for now, the firewall is more defined to control traffic and all the way and protect your network from any sort of infiltration or exfiltration that can be there. That's it in this video. Hope this has been informative to you. If you like the content, please share your comments and feedback. And if you want to understand any topic in detail, I will buy some time to curate the video for this your interested topic as well. You could mention that on chat. And that's it for now. Thank you.